All right, everyone, welcome to section 8.2 on linear functions. This is Nick Jacobs, your intermediate algebra instructor. So a few objectives for today. We're going to recognize representations of linear functions, recognize graphs of linear functions, model data with linear functions, and apply the midpoint formula. Although the midpoint formula I will not have in your homework currently or your quiz or test, but we may come back to it later. All right, a linear function. So you probably remember this from algebra as a line. Basically, y equals mx plus b. But you know that with functions, we use f of x in place of y. Okay, the x value is still x. It's just what is your output, right? When your input is x, right? M and b, right, are constants. And you may remember, again, that m means the slope or the rate of change, right? The slope or rate of change. And b is where the line crosses the y-axis, which would be, whoops, that's y. Sorry, that's y, the y-intercept. All right, that's what a linear function kind of looks like. It has a slope. It has a variable x, by the way, with an exponent of 1. It always has to be an exponent of 1 for it to be a linear function. And then it is always going to have a y-intercept at some point. So let's determine whether f is a linear function. If f is a linear function, find values for m, the slope, and b, the y-intercept, so that we can have this form, f of x equals mx plus b. So all we have to do is, and you can probably see it without rearranging, but we will rearranging it using the commutative property. All we're going to do here is switch around the positive 6, right? The sign in front of the 6 is positive, and the negative 2x, right? Or minus 2x. So I'm just going to flip-flop those. And now it looks like our y equals mx plus b, or f of x equals mx plus b. So I guess the first question was, before I get into slope and y-intercept, the first question was, is this a linear function? And yes, it is linear because the exponent of x is 1. And by the way, it has an x value. If it was just f of x equals 6, that would not be a linear function. It wouldn't be a function of at all. It would just be well, it would be a line, but it wouldn't be a function necessarily. So let's say yes, this is linear because x has an exponent of 1, or it's just a power of 1. And then the m value, what is the m value? Well, the m value is just the number or the coefficient in front of x. So -2. So the slope is -2 on this line. And the y-intercept is 6. Now, generally, for a y-intercept, right, what would this line kind of look like? Let's just review a little bit. Okay, so here's our graph. It's a bad arrow, apologize. But really, the y-intercept is at 6 on the y-axis, right? So 6 is somewhere up here, and really this point is at 0, 6, right? Because it's when x has a value of 0, and then it has a slope of -2, and the negative slope, right, if you recall, tells us that the line is going in the downward direction from that point. So it's going down from left to right. Okay. And I'm not gonna say where does this cross the x-axis or whatever. We could find that, but that would be what it generally looks like. And for the next question, f of x equals 3x squared minus 5, is that linear? Well, no, it's not. It's not linear. And why? Okay, well, because it has an exponent of 2. okay, because exponent is something other than 1. And later in this chapter, we're going to learn that a function, this is a function with a exponent of 2 is generally going to be a parabola, or it's going to be something like this sort of shape, either up or down. They could also be like this, or possibly like that. Okay, but generally one of these two, but this is not linear. Linear just means a line, right? Does it make a line? All right, use the table of values to determine, so not just another example. Let's determine whether f of x could represent a linear function. So we're using a table in this case. If f could be linear, write the formula for f in the form of f of x equals mx plus b. So basically what I'm looking for here is there a constant rate of change? Because if there is a constant rate of change, that means that we have a linear function. It would form a line, okay? If it wasn't constant, if we have a graph, and we have a line, and then suddenly it increased a lot, and maybe it decreased, and then it increased, okay, that's not a line. We need it to be something that is constant, okay? How do we do that? Well, let's just look at how the values increase. So we see here that on the top, these are just going up by 1. So +1, +1, +1. And these values are going up by 7 every time, okay? So that would mean we have a linear function. Okay, so we can write this in the form f of x equals mx plus b. Okay, so this is linear. And what is the slope? Okay, so we need to know two things, right? So if we want to write it in the form f of x equals mx plus b, we need to know m and we need to know b. We're not going to fill in anything for x. Okay, x is something that we can put in and get an output, right? So I can put in an output, or sorry, I can put in an input of, say 1 for x. And by filling in the slope and the y-intercept like we're going to do, I should get an output of 11. Okay. Well, what is the slope going to be? The slope is this guy. It's the 7. It's as x increases, how does that affect f of x, or how does it affect y? Again, you can kind of think this is x and y. Okay. Sometimes we call these, this is the, and again, you might recall this from algebra, but this is the independent variable and this is the dependent variable, okay? Because y depends on x, okay? But our slope here, or m is going to be 7. What's b? What's the y-intercept? Well, if you recall from kind of my previous picture, here, our y-intercept is when x is 0. Okay, so in this case, it was 0, 6. Okay, well, when is x 0 in this case in the table? Well, when x is 0, y is 4. So our y-intercept is going to be 4, or b is going to be 4. Okay. So, and you can kind of check this. You can check to see if your formula is right. Like I said before, once you think you have it, plug it in, right? Plug 1 in for x. Do we get an output of 11? Yeah, 7 times 1 is 7, plus 4 is 11. 7 times 2 is 14, plus 4 is 18. 7 times 3 is 21, plus 4 is 25. So all those check out, including the 0, right? 7 times 0 is 0, plus 4 is 4, and we get that output. How else could we check? How else could we check if this is linear? Well, we could just graph it, right? We could just graph it. And if these points all line up, then it would be a line, and it would. You guys can try that if you have graph paper. All right, sketch the graph of this function, f of x equals x minus 3. Use the graph to evaluate f of 4. So let's begin by creating a table. I don't know. Yep. Okay. I got that table in there. So if you recall back to algebra, when you are making a table, you can pick any points that you want to be in the table. I usually pick points that are really easy to use, not big numbers. Okay, I pick smaller numbers. The only time I might pick big numbers is if I have a fraction in here, and then I'm going to want to try to pick numbers to clear out the fraction. Like for example, if I had, if this was f of x equals 1/5 x minus 3, I would pick multiples of 5 because that's going to allow any output to give me a whole number. So for my inputs x, I would choose multiples of 5 for this case. In this case, it doesn't matter. I'm just going to choose, let's say, -1. I always maybe choose a negative number there. 0, 1, and 2. Okay, and let's plug all those into the function here to get outputs. So you might remember this from algebra again. So y, what is y? Well, y is f of x, right? And f of x, which is y, equals x minus 3. So all I have to do is take x minus 3 to get my y value. So I take -1 minus 3. So -1 is the value I chose for x, and that's going to equal -4. 0 minus 3 equals -3. 1 minus, I just wrote the 2 there. 1 minus 3 is -2. And then 1 minus 2 is -1. So our points are -1, -4. 0, comma, -3. Remember, it's always x first, then y. For those of you who haven't had math in a while, I'm working harder now after the first chapter to not make assumptions about things, as I've worked with some of you on questions. So, and that's okay. Sometimes we can do review within a lesson. So let's now plot these points. So again, we have our y-axis, we have our x-axis, we have an x-y point of -1, -4. So -1 is here, and on the x-axis down to -4. Oops. Sometimes this is a little tricky with my my pen, my smart pen thing that I'm using. We have a point that's 0. Oops. Hopefully it's not going to erase those every time. 0, -3, 1, -2, and then 2, -1. There we go. And then I should have clicked ahead because it says plot the points, right? And sketch a line through the points. So I just plotted those 4 points. If you want to label them, you can, right? This point was at -1, -4. This point is at 0, -3. That's your y-intercept, by the way. And that makes sense. Why does that make sense? That's the y-intercept because look at your equation, x minus 3. Oh, b, the value that's over here is -3. Okay, and then we had 1, -2, and then 2, -1. And you don't have to do that, but just because, and I cannot really draw a straight line with this pen, but we'll go with that. Okay, that's what that graph is going to look like. All right, so that's a better line. I kind of left what they had there. So sketch the graph of f of x equals x minus 3. I just did that. I did that on the last slide. But let's use the graph to evaluate f of 4. So use the graph to evaluate. There's 2 different ways, right? You could use this formula, and I'll do that in a second, but let's just use the graph. Let's follow their directions. Well, a graph to evaluate f of 4 means when we have an x value of 4, because they put this is our x, what is y? So what is, so f of 4, the y value, what is that equal to, right? When x is 4. Well, when x is 4, y is 1. So they're talking about this point right here. They're talking about the point 4, oops, not 4, -1. I don't know why I wanted to write a negative there. I'll erase that. I'm talking about the point 4, comma 1. Okay, so when x is 4, y is 1. This whole thing means y. Y is 1. We had an input of 4 for x. Hopefully that makes sense to you. Check my notes, see if I had anything else I wanted to mention on that. The only other thing that I wanted to mention was using the formula, right? Or not, it's not really a formula. I keep calling it a formula. It's really an equation. It's an equation of a line, an equation of a linear function. So all I do is kind of what I did before. I put 4 in for x, and I should get the same thing. So f of 4 is 1. There we go. That's another way to do it. All right, let's try to model some data with linear functions. So I don't know why I used a and x here. Okay, just maybe because it's a little bit different here. This is like talking about change here. You know, we can still use m and b instead of a here. I don't know why I really used a. That's not necessary. But we can interpret this as, you know, a new amount. This will make more sense in a second. We can interpret this as a new amount equals the change plus the fixed amount. Okay, well, what do I really mean? Okay, so I mean that if we want to know a future amount, we can take the rate of change, which is our slope, times x, which is time. It's something that constantly goes up. It's independent. Remember, I talked about independent variable versus dependent variable. Time is independent. Okay, it's like a almost like a, I don't want to say the word fixed, but it's something that it just keeps going up. Okay, or down. Okay, but anyway, and then b in this case is a fixed amount, or it could be an initial amount. Let's take a look at an example of what I'm talking about. It'll make more sense. So suppose a moving truck costs 25 cents a mile, and there's a fixed rental fee of $20. Find a formula for a linear function that models the rental fees. Okay, what would the rental fee be for 150 miles driven? So there's a couple of different questions here. We need to find a formula for the linear function that models rental fees, and then we would need to answer what would the rental fee be for 150 miles driven. So two different things we have to know. Well, if we kind of go back to our formula, we have a future amount is equal to a rate of change times time plus an initial amount. Okay, so if we have a future amount, okay, equals a rate of change, okay, times time plus an initial amount. Okay, let's try and come up with a formula of what this would be. Well, for a future amount, I'm just going to use f of x. Okay, it's our function. I need to come up with a function or a formula for a future amount. Well, what's the rate of change in this case? So suppose a moving truck costs 25 cents a mile and a fixed rental fee. We have a fixed rental fee of $20. Okay, well, the rate of change would be the 25 cents, right, for every mile. Okay, so the rate of change would be the 0.25. Time is x. Okay, meaning that it, again, is independent. It's just something that keeps going up. You could also use t if you want to. I just don't want to confuse it with the plus sign. But then the initial amount for that moving truck is $20, because that's your rental fee. Okay, maybe some of you are, if you needed to maybe move into campus, or maybe you've moved in the past somewhere, you've had to get a moving truck, and you would kind of know what that entails, right? It has a fixed fee plus your cost per mile. But this is the formula for that, okay? So this is one of the answers, okay? That's your formula for a linear function that models the rental fees. Now, what would the rental fee be for 150 miles driven, okay? And actually, I think I might have messed up because it's the rate of change per mile. I put time. I was thinking back to the other question. I probably meant miles, but I said time. Okay, this is miles, how many miles you drive. Okay, so X really means X is number of miles. So if I drive 150 miles, what is the cost of that? Well, I would just take the 150 and I would plug it in anywhere that I see an X. And so if I have an input of 150 miles, you guys can do that on your calculator quick. I took a little shortcut and I solved it there, but that would be 57.50 if I drove 150 miles in this scenario. All right, let's do a little bit of another example here. So the temperature of a hot tub is recorded at regular intervals. We have an elapsed time in hours and then a temperature here. Well, let's discuss the temperature of the water during this time interval. So what seems to be happening here with the temperature? Well, it looks pretty constant to me, right? So it's always 102 degrees Fahrenheit, even after every hour, okay? So the time, or sorry, not the time, the temperature, temp is constant at 102 degrees Fahrenheit. And then the next question they might ask is find a formula for the function that models these data, okay? Well, so the first, again, when we're writing the formula, we kind of need to know this, right? F of X equals MX plus B. What's the slope here? Well, the slope would be, well, what is this rate of change? Well, nothing's happening here, right? You guys think back to the last example, it's 0. So the rate of change is 0. Rate of change is 0. So it doesn't have a slope. Okay, it doesn't have a slope. So it's 0x plus what? Well, plus b. Where does it intersect the y-axis? If we were to draw this out, where x, right? X and y, that's where x is 0. And that intersects at 102. Okay, so our formula would be f of x equals 0x plus 1 or plus 102, or f of x equals 102, because 0 times x is going to be 0. There is no slope here. This is constant. So if I had to draw this out, okay, what would this look like? Well, y is 102. So if this is the y-axis, this is 102 all the way up here. Oops, I just lost that there. Sorry about that. But I would have that every x value, it has y is 102. So I would just have a straight horizontal line. That's what that would look like. Okay, it is a function because it passes. Remember, we learned about the vertical line test last section. This is a function. It's just constant. Okay, it's just a straight line, straight across. All right. Let's just sketch a graph of that. I just did that. Okay, this is kind of what the graph would look like. And they only did it from 0 to 3. Really, this could keep going. And actually, I had some negatives in there that actually would not make sense because time cannot be negative. So you can kind of almost ignore my graph. On the last page, I was just kind of showing you what a constant function would look like. But I don't want you to get confused with that. All right, a couple more things. Let's do a question on the homework. I don't remember which question this is, but it's on 8.1 through 8.2. Obviously, this will be one of the questions that starts with 8.2 point something, okay? So the number of email users, E, in millions, X years after 2006 can be modeled by the formula E, they really should say by the equation or the function. E of X equals 103X plus 145. How many users were there in 2011? So a couple different things we need to note here. We have millions, so the number of email users in millions, okay? So when it says million email users here, we don't have to worry about changing this number. I'll talk about that more in a second. But it's X years after 2006. So the first question you have to ask is, how many years after 2006 is 2011? Well, 2011 minus 2006 is 5. So it's 5 years after 2006. So, and it's X years after that. So X means the number of years after 2006. So all I have to do is take the formula here and substitute 5, because 2011 is 5 years after 2006. I just have to substitute 5 for X. And I get, let's see, what did I get here? 660. And this is really 660 million. But the 660 is what you would enter in that box there. Now, part B said, what does the number of 145 indicate in the formula? Well, remember, this is B, this is M, our rate of change, and this is our initial value, right? You guys can even go back, right? Go back to this page. I don't want to go back too far. Go back to this, right? It's the initial amount, right? And M is the rate of change. So in the 145 represents in 2006, how many million email users there were. So the 145 represents the 145 million email users in 2006, right? Or the number of, and your options might be a little bit different than that. It might say something like the number of email users in 2006 or something like that. C, what does the number 103 indicate? Well, that's the rate of change, right? So it's basically the rate of change in millions of email users per year. Okay, and it increases by 103 million every year. That's what the 103 means. It's the slope, the rate of change. All right, the last thing that I'm going to quickly go through, and again, I said earlier, this is not on homework or a quiz, but we may refer back to it later, is the midpoint of a line segment. Okay, so if you have a line, okay, on a graph, okay, and you have 2 points, okay, what is the midpoint of those? Okay, this formula would tell you the exact midpoint. Okay, this is the midpoint formula. We're not going to really use this yet, but we may come back to it. So the formula goes like this. If you have 2 points, right, maybe this is x1, y1, and this is x2, y2, I can use this formula to find m, the midpoint. Okay, so let's go to an example here. Find the midpoint of the line segment connecting the points -3, 4, and 5, -3. So the first thing that I'm going to do is just label these points, x1, y1. This is x2, y2. So I just remember that the formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That would be the midpoint of those 2 points. So let's just fill in the numbers here. So x1 was -3, x2 is 5 divided by 2, y1 is 4, and plus -3, right up there, divided by 2. So we just basically cut the line in half. That's why we divide it by 2. But that's going to give us -3 plus 5 is 2 divided by 2. 4 plus -3 is 1 divided by 2. So the midpoint there, 2 divided by 2 is 1. And we just keep the 1/2. So this is your answer. And that is section 8.2. So if you have other questions, please let me know as you work through the homework 8.1 through 8.2. Otherwise, we'll see you next time for 8.3. Have a good one.